This is Mix Martin with some unit conversion. So our table is up here with our prefixes. The most important ones for us, for biology, are centi, milli, micro, and nano. So take a look at the powers of 10 that these correspond to, and we're going to try to do a practice problem. So the practice problem is how many micrometers is how we pronounce that. Micron is another way of saying the same thing. So how many microns, or how many micrometers, this is the Greek letter mu, so this mu m is micrometers. How many micrometers in a centimeter? I'm going to show you a few ways to solve it. So how many micrometers in a centimeter? So here's micrometers, okay, 10 to the negative 6, centimeters, 10 to the negative 2. Okay, how many micrometers in a centimeter? So one way we can set this up is to sort of represent it algebraically. So I'm trying to figure out how many, x for how many micrometers in a centimeter is equal to 1 centimeter. How many micrometers in 1 centimeter? And if we know the powers of 10 that correspond to these, we can just replace, okay, micrometer is 10 to the negative 6 meters, and centimeter, 1 centimeter, so we don't have to write the 1 again. Centimeter, 10 to the negative 2 meters. Do you see how that's equivalent? So 1 micrometer is 10 to the negative 6 meters, 1 centimeter, 10 to the negative 2 meters. And then we can just treat this like it's algebra. So we divide both sides by 10 to the negative 6. So it's 10 to the negative 2 meters over 10 to the negative 6 meters. We can happily cancel our units, which should make sense. And then if I can remind us of the algebraic rules of exponents, a to the power of m divided by a to the power of n is equal to a to the power of m minus n. Okay? So now all we have to do is look at our exponents here, negative 2 and negative 6. This is the same as 10 to the power of negative 2 minus a negative 6, which is the same as negative 2 plus 6, right? So it's 10 to the power of 4. So x equals 10 to the power of 4. So the sentence we can write is there are 10 to the power of 4 micrometers in 1 centimeter. Okay. 10 to the power of 4 micrometers in 1 centimeter. I'm still getting used to the document camera, forgive me. We could do this in a more dimensional analysis looking way, or a factor label looking way. It's algebraically equivalent, but it might be a little bit easier to follow for some of us, so I'll do it. Let me draw a line. This is the same question, but a very slightly different approach. So we are trying to convert now centimeters to micrometers. So 1 centimeter, and then we're going to set up 3 conversion factors. So we want to convert from centimeters to micrometers. Well, we can't do that directly, but I know we want to end up in micrometers, so I put micrometers here. So we want something that's going to cancel out centimeters, and so we need to go through meters. So I'm going to put centimeters down here, meters up here, meters here. So if we look at this, we're going to be able to cancel out centimeters, centimeters, meters, meters, and we'll get our answer in micrometers, which is what we want. But of course, the most important thing is to actually put in numbers here. So if we know 1 centimeter is equivalent to 10 to the negative 2 meters, and we know 1 micrometer is equal to 10 to the negative 6 meters. Okay, I hope that makes sense. So 1 micrometer is 10 to the negative 6 meters. 1 centimeter is 10 to the negative 2 meters. So then we just multiply across 1 times 10 to the negative 2 times 1 all over 1 times 10 to the negative 6. So it's 10 to the negative 2 over 10 to the negative 6 unit of micrometers. It's the same algebraic situation, right? Using that rule, we know this is 10 to the power of negative 2 minus a negative 6. So it's 10 to the positive 4 micrometers. And so we have the same answer, same relationship. 10 to the power of 4 micrometers is equal to 1 centimeter. And if we want to get rid of the powers of 4, 10 to the power of 4 is 10,000 micrometers in 1 centimeter.